Welcome to today's webinar on root rot. My name is Mark Zatylny, and I'm the Agronomy Manager with Saskatchewan Pulse Growers. I will be your host for today. For those in attendance today who provided a CCA number at registration, we will apply for your CEUs on your behalf. SPG continues to focus on the most significant challenges facing pulse growers, guided by our strategic plan. These areas of focus are research and development, market diversification, engagement and extension, and market access and advocacy initiatives to create profitable growth for Saskatchewan pulses. Today we'll be using Slido. So on your device, you can go to slido.com and enter the event code at the top of the screen, or scan the QR code with your phone. At the end, there'll be a live question and answer discussion. So if you have any questions, please type them in the Q&A tab in Slido, and feel free to add your questions at any point during the presentation. There will also be a couple interactive elements that will appear in the polls tab as we go. And if you have any technical difficulties, just send us a message using the Slido Q&A tab, and we will assist you there. So what are we talking about today? So the first one, we'll be going through just a quick review of the root rot complex and the different pathogens involved there, scouting, prevention, and management tips, soil and tissue testing, root rot research, and then finish off with the 2025 Saskatchewan Disease Survey results. So starting with the root rot complex, I've got a quick question here to kind of test you all on your Slido using ability. And just this question here is, have you or a grower you know changed your rotation strategy due to root rot pressure? I'll just give it a couple seconds here for more people to answer this one before we move on. All right, perfect. I'm glad to see that majority of you have had to change your, well, have changed your rotation strategy. Not so great that you have to due to having root rot pressure. So we'll get into the pathogen complex itself. In the next couple slides, you'll be hearing me say pathogen complex a lot, so that's just a preemptive warning there. But in this complex, the four main pathogens we deal with are Aphanomyces, Fusarium, Pythium, and Rhizoctonia. Unfortunately, as we continue to do research into these pathogens, that complex kind of becomes more complicated and is in a complex itself. So each of those different pathogens, they can also then be broken down into these kind of subspecies in those main species. So this is really kind of adding to the complication that growers deal with when managing Aphanomyces and Fusarium in the field. And as well with this, different crops and different varieties all have variable susceptibility to these pathogens, so they all don't impact the crops all the same. Thankfully, though, we do know that in Saskatchewan, there are three major pathogens that growers deal with. So we've got Aphanomyces euteiches, Fusarium avinaceum, and Fusarium solani. And here in these graphs, we're just kind of showing the different prevalence or percentage of positive fields that were tested, the percentage that have these major pathogens in them for peas and lentils. And you can see it is pretty variable over the years, depending on environmental conditions and kind of how much pathogen is out there. Going into a little bit more detail about Aphanomyces, so kind of what we know so far. Aphanomyces is a water mold with long-lived resting oospores in the soil. These germinate into zoospores that then swim through water in the soil and infect the host plant roots. Kind of one of the key requirements is moisture for that infection to occur. So if you have the pathogen present, but it's a very dry year, there is a good chance that you might not see any negative impacts from Aphanomyces. But if there is a lot of moisture, then those zoospores can come in contact with the roots and infect them. Aphanomyces also prefers that warmer soil temperatures and is often working to infect plants in combination with other root rot pathogens. There are seed treatments available, but they only provide early season suppression, and Aphanomyces unfortunately can infect a plant at any growth stage. What we do know regarding the susceptibility of pulses and soybeans to Aphanomyces is presented here. So obviously, peas and lentils are the most susceptible, as well as being equally susceptible to Aphanomyces. Dry beans depend on the variety, as some have more resistance than others. Faba beans, the most recent work by Dr. Larkin, is showing that certain isolates of Aphanomyces can impact faba beans, but it's also very variety specific. And I'll show a couple examples of this later in the presentation. Chickpeas are typically grown in the drier areas of the province, but they are showing partial resistance. And while Aphanomyces can be detected in the roots, it doesn't seem to really impact the plant and cause any reduction in yield. Fenugreek, we suspect, is a non-host crop, along with soybeans and lupins. As fusarium species are kind of the other two aspects of the top three pathogens that growers are dealing with in Saskatchewan, here's just some more details on that. Unfortunately, pulses are more susceptible to fusarium than other crops, and fusarium itself really has a wide host range compared to Aphanomyces, where it will impact cereals and oil seeds. So that is kind of a negative and kind of ties into how just having a good crop rotation alone is ineffective for dealing with fusarium root rot management, as it's kind of pretty difficult to rotate out of all the crops that could be impacted by fusarium. With fusarium, though, pretty similar in a lot of ways to Aphanomyces. It likes those warmer temperatures, some soil moisture. It doesn't require that high moisture that Aphanomyces does to impact the roots, but it is another one that growers have to really watch out for. And with Fusarium, you really want high quality seed that might have some moderate resistance that is bred into those varieties, as well as there are seed treatments to provide that early season protection. Like kind of all the root rots I'll be talking about, it can impact the crop at any growth stage, but typically is kind of in that earlier season when the crop is usually more stressed, just trying to get out of the ground and get going. Here is just a quick glimpse from the seed guide where you can look for that moderate resistance in field peas, and varieties are continually being looked at for resistance to root rot. And while I said that chickpeas show partial resistance to Aphanomyces, they can still get root rots. And so in 2025, there were quite a few inquiries coming in from newer chickpea growers and even some experienced growers about plants yellowing and wilting. The grower would go out, pull them out of the ground, and a lot of it turned out to be root rot. The common symptom we saw was blackening and shrinking of the root crown, which led us to believe that it was probably a fusarium that caused this infection. The graphs on the right here are showing some testing by Dr. Benitza that she did at the CDC, looking at pea, lentil, and chickpea fusarium resistance across various varieties and breeding lines. As you can see in the pea and lentil at the top and middle there was a more linear response of how much discoloration they showed across varieties. But then when you go to the chickpeas at the bottom there, we only really have 5 varieties that were showing some type of resistance, whereas 90 to 100% discoloration of those remaining tested lines were impacted. So chickpeas are an option when we have Aphanomyces issues, but need to consider and be aware that they aren't immune to other root rot pathogens and are possibly even a bit more susceptible to Fusarium avinaceum than peas or lentils are. As this is that root rot complex, outside of Fusarium and Aphanomyces, there are a couple more players in the game here. So the next one is Pythium. This one prefers it a little bit cooler, but still in very active growing temperatures for the crop. They again like that wet soil. This one, in a couple ways, is similar to Aphanomyces, where it has those oospores in the soil that can then kind of have that longevity in the soil and live through other non-host plants. And it is a major issue in Kabuli chickpeas that we do see out there. Another one is Rhizoctonia solani. So this one has a wide host range. It's a true fungi, and it likes, again, those warmer temperatures, doesn't quite need all the moisture that other root rots need, and really can impact a crop once it has that early season stress. Rhizoctonia is quick to get in there and infect the seedlings. And if it doesn't fully kill those seedlings, you're going to have pretty stunted and less productive crop throughout the season. And the last one I want to talk about is Phytophthora. So this is a root and stem disease specific to soybeans. It's similar to Aphanomyces in a lot of ways, but it does primarily just impact soybeans at any developmental stage again. But it creates those oospores. They aren't quite as long-lived in the soil as Aphanomyces. These are only a handful of years, where the Aphanomyces ones can be 10 plus years. But in a lot of ways, it kind of interacts with the crop the same, infecting the same, and really getting that reduction in yield and killing off the plants. So now that we kind of have a better understanding of these various pathogens, what can growers do today to help manage this? So the first thing a grower can do is scout early and scout often. So from crop emergence until flowering, those are really when the crop is most easily impacted by the pathogen, and will have the largest impact on your yield. The earlier that it gets infected, the more loss in yield you're likely to get as the crop develops. And root rot will typically set in based on environmental conditions once that feed treatment wears off around 28 to 35 days post-seeding. When you're out looking at your field, you do want to target those lower areas where you kind of have typically seen water standing, or where the soil is more compacted or any water runs through your field, really where there is kind of a lot of moisture that's involved. You just want to get out there and then dig up the plant, look at the roots. It's not the easiest to distinguish between all the different pathogens, but it is pretty easy to know whether you have a root rot or not based on looking at the roots. And if you're unsure, collect soil and tissue samples, and you can submit those to a bunch of labs in the province. Some ways that a grower can mitigate root rots if they have identified them in the field. So really the first step is prevention through crop rotation. Having non-host crops in rotation is important to keep the soil pathogen load at a minimum and not letting it build up, just infecting over and over pulses as you have them. Seed treatments, again, it is just really that early season protection, giving your crop the best chance to be healthy and vigorous so that it has just some innate resistance to getting infected by root rot pathogens. The more robust and healthy your crop is, it is just naturally able to kind of combat root rot, as really a stressed plant is the first pathway to be infected by a root rot. Again, you don't want to roll your pulses when the soil is wet, so this kind of can increase compaction, increases that plant stress, and creates poor drainage, all the things that really let root rot thrive in a field. Lighter texture soils, good drainage, keeping that water to a minimum when you can, just so that those zoospores aren't swimming around infecting your roots. Control any other hosts, such as volunteers or weeds, when you're in rotation with non-host crops. And just give the crop the best possible start with having high quality seed treatments, good location, and just hope those environmental factors all align and can kind of keep root rots at bay. Here's just a nice demonstration of why that rotation really matters. So this is a field that had peas grown in it. On the left side there is a 4-year rotation, and on the right side is an 8-year rotation. And you can see that that 4-year pea field is kind of suffering a lot more from root rot than the 8-year rotation. That looks like a pretty lush and healthy crop. Once you've kind of got the scouting down and know your fields pretty well, we do have several tools available to growers and agronomists to better understand what fields have a higher risk of root rot infections. So this one is just a quick checklist that's available on saskpulse.com and rootrot.ca. And it just allows a grower to go through the various risk factors that they will know from their fields and kind of give you a better understanding if you're at high or low risk for having a root rot problem. Another really valuable resource is the Aphanomyces Risk Evaluation app, or AREA. So this was created by Dr. Shurtleff and the Agronomic Crop Imaging Lab at the U of S. It uses historical satellite data to determine previous crop rotation history, as well as historical precipitation to determine the risk of Aphanomyces. So this really, you can just go to the app and find a field in the province, and it will kind of just give you a general risk assessment of if you should be on the lookout for Aphanomyces in your field. There's that QR code at the bottom left that will take you directly to the app. You can also go to our website to find it there, as well as just Google Aphanomyces app, and it will be the first link that you'll see there. So, as I mentioned earlier, there are soil and tissue testing options for growers. First one is soil samples. So this one, lots of different labs are doing testing through the soil. So like there's 2020 Discovery Seed Labs, several more that you can find on the SPG website for just a standard Aphanomyces soil test. You do want to be sure that you request the pathogen load when you go through this process, as typically you'll just receive a yes or no answer for the presence of Aphanomyces, but you can request a numerical result of oospores per gram of soil. We continue to do a lot of work on identifying a more precise spore per gram infection rate. But right now we're kind of sitting at around 100 oospores per gram, but that is variable depending on environmental conditions as well as the variety of crop that you're growing. I have seen sites with really crazy high pathogen loads, but then had zero infection due to the environmental conditions. For tissue samples, you will want to contact the specific lab that you work with, as some will want full plants, some just want roots, and storage and shipping requirements may also differ depending on the lab that you go to. Many of the labs, though, are also offering bait testing. So this is where you'll collect a standard soil sample, send it to the lab, and then they will grow a host plant in that soil sample, extract the Aphanomyces DNA straight from the roots after the oospores have germinated, and then you'll know whether there's Aphanomyces or not in that soil. They don't need to go through the process of cracking open the oospores, which is a difficult process to do, as well as not always fully reliable. And I'll show that here. So this is a bait test versus a direct soil extraction that we did a case study in 2022. So you can see from the 3 different sampling locations, the bait test all showed that there was more infection than the direct soil extraction showed. So that does show that there is a higher incidence of false negatives when just using the soil extraction method due to how difficult it is to work with Aphanomyces oospores in the soil. Now we'll go back to Slido here. So having gone through kind of what growers can currently do on their operations, and before I get into all the research that's being worked on, what are some of the biggest challenges that growers face when managing root rot? And this, you can just go in and type your answer. It's a word cloud, and they'll just kind of pop up as you type. And we can spend a couple minutes here chatting about what people write in. Oh, well, helpless. That's a rough one. Hopefully, after this, you won't feel that way. Yeah, so it does look like really the good thing is that you seem to be still trying to fit pulses into your rotation, as that is important. And we have all the data to show how valuable it is to have a pulse crop in your rotation um, for a multitude of reasons. But yeah, trying to find ones that fit and can help resist that Aphanomyces and other root rot pathogen infection is a difficult um, challenge to manage. Hopefully, when we go to the research section, it will give some hope to growers that there is potentially a light at the end of the tunnel for dealing with the root rot complex. So I will get into that research now. Because we're talking about diseases, we can't help but talk about the disease triangle that I'm sure majority of people will have either seen or heard about. And in this next section, I'm really just going to be showing the work being done in each of these three aspects of the triangle: the pathogen, the environment, and over the past 12 years, SPG has committed $20 million leveraged through various organizations and programs, resulting in 53.5 million in research commitments. As you can see here, out of the 55 projects, 20 have been completed, while 35 are still underway and represent 17 million of SPG's 20 million commitment. In other words, there's still a lot of research underway with results yet to be determined. First, I'm going to look at the pathogen research. So we've got 24 projects that fit into this space with $3.6 million from SPG committed. The first one here is, so we've done a lot of work with Aphanomyces itself, and we've learned a lot about it in the past decade, but there is still a lot of work being done to further that knowledge. It is a very difficult pathogen to work with in the lab, greenhouse, and field, so protocols are constantly being refined and developed to allow for more consistent testing. And as you can see, and I've mentioned, Aphanomyces is not the same in every field. So if you look at the graph here, so this is that work done by Dr. Larkin that I mentioned earlier about the Aphanomyces isolates. So in that first image there, that is one isolate that impacts faba beans, lentils, and peas fairly equally. The second isolate is just impacting lentils and peas. And then that third one is just impacting peas itself. So while it's Aphanomyces, those different isolates in that complex of Aphanomyces itself can impact different crops and different varieties in unique ways. So it's not just a cut and dry Aphanomyces, solve that, we solve everything. There is a lot to look at in that and why all this research is being done. There's also all these other options that we're looking at through controlling the pathogen. So there are several biological products that we're looking at in fields to see if there's any results from that. Chemicals such as seed treatments are being researched. You can see here, this was using Rancona Trio, and for the majority, when that seed treatment was used, the root rot severity at these locations was reduced. So that is showing that there is still promise in these chemical treatments. RNAi technology, as well as combining host resistance plus control options and management strategies, using that all together to really combat and manage this issue. The next will be environmental research. So there are 4 projects going ahead here. So one of the big ones, as we know, is managing water, because that is one of the key things when the pathogen is present in the soil. Once you get that water, then the risk of infection greatly increases. So how can growers manage that using either drainage or just through field selection into that lighter land? How can that fit into rotation for growers? Another one is liming. So this has worked with Aphanomyces in sugar beets, but we haven't seen too much for positive results in Western Canada just yet. And thirdly is gypsum. So adding this to the soil. Calcium, we know, is involved in zoospore production and germination. So extra calcium may inhibit zoospore germination. In this middle chart here, you can see the one location was showing a reduced root rot rating there. So that has some promise that we continue to investigate. And we also saw increase in nodulation as well. Next is the host research. So this is by far the largest section that research is being done, with 27 projects and over 29 million invested into it. So the first one, and probably the one that is most tangible to a grower that they understand the most, is breeding for resistance. So with peas, there are doing crosses to stack partial resistance to Aphanomyces, as we have seen that some varieties do have more resistance than others. And so getting those genes stacked on top of each other to get increased resistance to Aphanomyces. Lentils, unfortunately, have no partial resistance in domestic lines, so we are going to have to introgress from wild types and then remove any negative traits that come along with that. We know from when you introduce herbicide tolerance to a crop, there's typically it impacts the yield or some other agronomic traits of the crop. So once we get kind of that potential resistance built in, we then have to do additional work to make sure that that yield is maintained for any varieties that come out of that breeding process. There's also mutagenesis. This is all about just creating diversity in existing high-performing lines. It's pretty quick, but it is just kind of shooting in the dark and hoping we hit something that provides resistance. Next, so with developing those different varieties through breeding, to accomplish all of that, we really need to provide breeders with some additional tools to kind of make it more manageable and speed up the timelines for these projects. So firstly, there are 15 genomic tool development projects happening with the ultimate goal of genetic tools that can ID resistance in germplasm without destroying seed. Being able to ensure the resistant genes are in the plants is the first step in developing a resistant variety. Then we need to ensure the resistance is actually expressed, which is where the phenotypic tools come into play. So there's two projects here, one looking at field evaluations to help breeders better choose varieties in the field. And the second is an Aphanomyces screening program with the Global Institute for Food Security. This project is funded by SPG and is set up to allow all the breeding organizations access to this tool where early generation lines can be tested for expression of Aphanomyces resistance. The graph here is showing the results from screening that was done this past winter, where out of all the lines bred for resistance, only 4% of them actually improved that resistance. So this tool allows the breeders to then focus on moving only that 4% of the lines into the field and focus on seed increases there to get a successful line to growers faster, instead of having to take some of those 96% other lines that already are failure and they can just be put aside. The third tool is then kind of taking all of this into predictive breeding. So this is where both the genomic and the phenomic data will be used to create a model that will predict which crosses to make to have the most success in breeding programs. This project is led by GIFs and funded through Protein Industries Canada, as well as the crop commissions, including SPG. And it's the first of its kind in Canada and includes all pea breeding organizations, both public and private. So it's really getting everyone involved with the tool to enable breeding to progress at a quicker pace and get these varieties with resistance into growers quickly. There is other research obviously going on with this resistance. So looking at susceptibility genes, root architecture, gene editing, and work with tannins in seed coat for fusarium, as we have seen some where there's darker seed coat, it is kind of less appealing to fusarium to infect. And also, kind of with all of this that you've talked about today, is just management with the hosts. So obviously, number one is still keeping that crop healthy to help it resist any infection by a root rot. Seeding date. So Aphanomyces does prefer that warm soil. If you seed a little bit earlier, hopefully the crop will be out of the ground and vigorous enough to just progress through the season. You obviously don't want to go too early, as then that seed hangs out in the soil longer. You lose that seed treatment efficacy because once that seed's in the ground with the seed treatment, the clock starts ticking there. It doesn't wait for it to germinate or anything. And you don't want to stress the plant based on those conditions. Again, seed treatment provides that early season suppression and helps kind of to manage all the pathogens in the root rot complex for that kind of first handful of weeks. Seeding depth, you want to make sure that you calibrated your equipment well to avoid stressing the plant, as if you go too deep, it has to expend a lot of energy to get out of the ground, and it will take longer, stressing the plant, making it more susceptible to infection. And of course, that 6 to 8 year rotation, knowing the risk that you have in your fields, being able to assess which ones are higher risks, helping you kind of manage your different rotational options. All of this also kind of ties into the root rot task force itself, where Saskatchewan Pulse Growers works in conjunction with Alberta Pulse and Manitoba Pulse and Soybean. So all three of these organizations are working together in this space to ensure that kind of all of this research funding and events like this, the communication, getting this information out to growers to know that there is a lot of work being done, how they can keep their fields profitable, manage root rot, and do the best that they can to be productive while knowing all the risks that come along with root rots. Here is just a glimpse of the rootrot.ca website. There's that QR code that'll take you directly to it, or just go to rootrot.ca. There's a lot of these different resources available there, as well as on the saskpulse.com website, and different resources, tools, and information on the various research projects and breeding projects going on. Next, I will just wrap this up with the survey results from 2025 for the root rots. So first, I want to start with a quick overview of prevalence and incidence. So the prevalence is how many fields in the survey will have detected a root rot pathogen, and then incidence is how many plants in that infected field had the disease show up. So starting with the lentil disease results, and this is how many fields showed disease of the 61 field survey. So no fields in the Northeast were surveyed, so I don't have any results from that area of the province, but root rot was showing up in 86% of the fields surveyed. The Northwest, Southeast, and West Central areas had the most root rot, and over 3/4 of all the fields in those regions showed symptoms of root rot. Looking at how many of the plants were showing disease in those fields, so the incidence, we saw high incidence of root rot everywhere except the Northwest, with over half the plants in all other regions showing signs of infection. 66% of plants had root rot. For severity of disease, root rots were the worst in the East Central. You can see there with the 3.7. Moving on to peas and the 47 fields surveyed here. So the high percentage of the fields showing signs of root rot at 87%. This did decrease a bit from 2024 numbers though, so that is positive. 100% of the fields surveyed outside of that central belt had root rot though, so it is very widespread across the growing regions in the province. Looking at the incidence for peas, the Northeast, Southeast, and Southwest had over half of the plants surveyed showing signs of root rot, and provincially 1 and 2 plants had root rot, with the worst severity in the Southeast and Southwest. A dry bean survey was conducted on 8 irrigated dry bean fields this year. Root rot showed up in roughly 1/3 of the plants that were identified. So I ran through that rather quickly. For any more information, go to saskpulse.com and rootrot.ca. Follow us on all of our socials. You can find my contact information on the SaskPulse website, so feel free to call, text, email with any pulse-related questions and root rot and research and whatever you have questions about, and I can either answer them or I'm able to direct you to the people that will have the answers to help growers and agronomists. With that, we can move into the questions here. If anybody has one, it's now's your time to start typing those up, and I will take the next handful of minutes to answer them. So the first one is, which labs are giving spore load numbers? So I know from my experience, I always go to Discovery Seed Labs, but there's like even 2020 and the other ones. So a lot of them will still do it. And you can find the full list on the saskpulse.com website. If I don't know it off the top of my head for the full extensive list. But a lot of them, when you submit a sample and you fill out the paperwork, it doesn't, like there's not really a space to write or like check off a box that you want the actual spore load in the soil. So I always have to write just in big bold letters that I want, like the pathogen load numerically given. That I seem to kind of have the best luck with getting that answer if you don't go through a direct bait test where you'll get that information. Are any lentil or pea varieties more resistant? Yes, so for peas, there are varieties that are more resistant to root rots. We are in the process of developing the results of that from this past 2 years of research to get out to growers where there is a difference in those varieties and which ones are more resistant than others. As for lentils, I'm not positive if we have that information or not. Um, I'm not sure, but peas, we definitely are working to get that information out to growers. Here's another one. I see that your Phantomyces seed treatment suppression trials were solely with Rancona trio. Any testing with other pulse seed treatment products, and if not, why? Um, I don't believe there are any ongoing ones right now with other seed treatments. I think the one with the Rancona trio was a pretty small project, but off the top of my head, I can't quite remember the details of the project. Um, and I believe it was chosen because it was showing the most promise and was the most like widely available product that could be used specifically for Phantomyces. But yes, there are other seed treatments and other companies with claims, um, and whether there will be continued independent research on that, I'm not sure. I can't answer that. Have AFC closures affected current research? I was hoping not to get this question. So this is still very much a kind of moving target where there's lots of questions in the air about what's going to happen. We do know that we have a lot of projects that are either being led by an AFC facility that's impacted or by one of the researchers or involved some way down the line with AFC. So there potentially is an impact. We just don't know the full story there yet of exactly for 2026 season how it's going to impact the current projects we have. Pretty much all the ones that I talked about today, they are long-term projects spanning several years. And so how that, if a project was just starting, how the AFC closures will impact that, or versus a project that has continued and is getting closer to the end. All those questions we're still working on identifying, and I think probably like 2026 will just be a year of all the commissions and all the research and AFC trying to kind of figure out best way forward of how to manage this and maintain the research that's being done. And so faba bean varieties, any showing better tolerance to root rot complex? Yes, so this kind of comes out of Dr. Larkin's research as well. So while we saw in that the data from him that the different isolates of Aphanomyces impact the various host crops differently, including faba beans, where some can be quite impactful to it and some aren't. It's the same with varieties where there are some varieties that are more susceptible and some have more resistance to the root rot complex. Uh, which ones? I don't know, but there is research being done in that field as well. to have that better identified. Do soybeans get root rot? Yes. So while soybeans don't get like Aphanomyces, for example, they do have their own group of root rots that impact them. A lot of the other ones in the complex will impact soybeans. And I know Manitoba has their own battle with root rot in soybeans, as they have many more acres than we do. So it's not a complete. If you grow soybeans, you'll never have a root infection of any kind. That's not the case. But for Aphanomyces in particular, an infection from that and producing more oospores in the soil, soybeans don't play in that field. And so you are protected from Aphanomyces with soybeans and can fit in your rotation for that. I've been growing chickpeas in fields instead of lentils, which seem to be very susceptible to Aphanomyces. Sounds like I still have to worry about Aphanomyces in those fields when I plant lentils. Those fields, the future. Yeah, so growing chickpeas is a really great option. I always kind of find that if you are a lentil grower, it's pretty easy to switch into chickpeas. They like the same kind of conditions and growing areas. And it is, so chickpeas typically, you won't see a yield reduction, and they won't be increasing the Aphanomyces oospores in the soil. So you won't know. It's not going to continue to increase and can be a little bit of a break in rotation. But the oospores do live for a long time in the soil, so they aren't just going to immediately go away because you're growing a non-host crop. They will potentially still be there and infect your lentils if you grow a couple years out from chickpeas. But it's a good option to include in your rotation and helps spread out those truly host crops like lentils that can really be negatively impacted by Aphanomyces. Can the soil fertility be important for the disease impact? Yes, so this kind of works in a couple ways. So we saw with having that increased calcium in the soil, that can help reduce the zoospores that are germinating and infecting your roots. But kind of more importantly and more easily to kind of incorporate and understand is that if you have a really good fertility package for your soil and your crop is going to have all the nutrients it needs, the crop itself is just going to be healthier and more robust, quickly to emerge, have everything it needs in the soil, not be particularly stressed due to a limit in nutrients. And so just having that itself will provide some support to the crop to not be impacted by one of the root rots. It's not obviously like a resistance or immunity to it, but just having that stronger crop does reduce the risk of it being infected by a root rot.
We have no more questions, Mark. This is our last call. If you have a question for Mark, please submit on Slido. Mark, let's just give it 30 seconds or so. Did you have anything else you wanted to mention? Anything those questions brought up for you?
No, I think, yeah, those are a lot of good questions. And I know it is, as we saw in that word cloud, a very complicated management situation. And it's kind of really something that particularly like Saskatchewan growers are concerned about and impacted by. And hopefully showing this research that is being done helps kind of alleviate some of the helplessness that one person put, that there is there's options currently available, and we continue to do a lot of work to hopefully, in the not too distant future, have some kind of more reliable solution and consistency to how to manage it and prevent root rot infection, all of that kind of hopefully was shown today.
We have no other questions for you, Mark. I just had one person ask whether this will be made available afterwards. Yes, it'll be posted on our YouTube channel and our website and sent to all participants, all registrants of this webinar shortly. So go ahead, Mark, you can close us out now.
Perfect, yes. So that concludes our program for today. We hope you found this meeting informative. Please take a few minutes to complete a survey to let us know what you liked about this and how we can improve any future meetings and what kind of information you want to get out of these. You'll also receive an email following this webinar with a link to that survey and, as Jasmine said, the recording of this. So yes, thank you for joining us today.